All right, there's some vocabulary words dealing with light that we probably should cover. So imagine that you have a light source. So imagine a light bulb right here, and light shining out in every direction. And light itself has energy in it, and we'll, in essence, cover that at some other point. But the energy in a light that's shooting out is equal to this constant here called Planck's constant times the wavelength of the light. So light is being shot out, and a certain amount of energy is being shot out within a certain amount of time. And so if you look at the amount of energy that is being produced in a certain amount of time by this light bulb, you get what is known as radiant flux. And the units are watts. Now, not all the energy that is coming off is visible. And so since we want to talk about the visible portion of it, we really don't talk about radiant flux as much, and instead we talk about something known as luminous flux. And so this is the energy per unit time that we can actually see. And so it's sort of skewed towards the sensitivity of light. It's not necessarily, not all visible light is treated the same, but that's the gist of it. And so luminous flux is basically what we see. And the symbol that your textbook uses is F for that. And the units of this luminous flux is the lumen, abbreviated LM. That's an L. The luminous flux talks about, basically it's the energy that is going out per unit time that's out in every direction. But if we focus in on just part of this, that, let's see how well I can draw a 3D drawing here. So if we're looking at sort of the amount that comes in this cone, then we are looking at what is known as the luminous intensity. And the symbol that the book uses is I for that. And so this is the luminous flux per solid angle. So that's a symbol for a solid angle. So if you imagine just an angle is sort of, if I have two-dimensional space, I have an angle right there, some angle theta. If I suddenly go into 3 dimensions, so imagine that I have a sphere, and at the center, from the center of the sphere to a little patch on the edge of the sphere, on the rim of the sphere, that creates a solid angle, and solid angle is part of a different video. So the units of luminous intensity would be, well, it'd have to be the units of luminous flux over the solid angle, so that's a lumen per steradian, which is the same thing as a candela. Now, this luminous intensity basically gives an idea how much light is sort of along a cone, or I guess a squared off cone, a pyramid. How much light is along a certain angle right there, but what really matters is what actually hits a surface. And so then we get into, so this light goes along, it hits a surface. That tells you the illuminance. So the illuminance is basically the luminous flux per square meter, because it actually hits a surface. So the symbol that the textbook uses is E, so that is the luminous flux over some area that actually gets hit. If you think about illumination, that something that is illuminated has a light on it or is basically made more visible. So illuminance deals with illumination. Matter of fact, the textbook calls it illumination. Other sources call it illuminance. So I should put parenthetically the illumination. And so the units of illuminance or illumination would be the units of flux, which is the lumen, per square meter, and that is known as the lux. Now there's another term which is similar to it called luminance, or probably illumination, and I don't think the textbook actually talks about it. Illuminance deals with the flux that coming off of a surface. Illuminance is the flux that hits a surface. Luminance is the flux that leaves a certain area. And so the sort of the memory trick is that illuminance starts with an I as an incident. So the incident light, that which hits, and luminance starts with an L as in leaving. So a bulb has a certain amount of luminance, or after the light shines and hits a surface, then the luminance comes off. Luminance is a measure of what is coming off, whereas illuminance is a measure of what's actually hitting the surface. And sometimes the terms brightness are involved. I've seen brightness involved with both of these terms, but that it's sort of just a general rule of thumb, technically not scientific. So those are some of the terminology that you'll run into. The textbook talks about these three things right here, and this is just in case you run across it. Now, a question I will ask you is that if I have a light bulb that is shining, and I am standing here, a certain amount is going to hit my eye. So just imagine that I've got this cone right here hitting my eye, and now I move in closer, still looking at that same cone. Which of these changes? Or if we imagine that the surface of my eye is basically the surface area, and so that as I get closer, the angle, the solid angle gets bigger because my eye is closer to it, then which of these changes for that?